Welcome to online studies of Ashadip International School. Standard 10, Subject Mathematics, Chapter 13, Surface Area and Volume. So let's start with the formulas. So these are the basic formula that we already learned or we already did in the Standard 9. Right, cube. So here curved surface area, total surface area and volume. So these are the basic formulas, so we have to go through these three formulas, right? So let's move ahead. So cube. So what is the curved surface area? 4a square. What is the total surface area? 6a square. Volume a cube. Cuboid, right? Cuboid 2HL plus 2HB plus, it's a curved surface area. So in the curved surface area, or you can say lateral surface area, curved surface area or lateral surface area. In curved surface area or lateral surface area, we don't have to consider the top part and the bottom part, right? So that is why 2HL plus 2HB. So 2H common. So this is the answer, 2H in bracket L plus B. So it's H into perimeter of rectangle. Why perimeter of rectangle? Because 2 in bracket L plus B is nothing but the perimeter of rectangle. That's why we'll take H in a side, so it's a perimeter of the rectangle, right? And what is total surface area? 2LBBH plus LH. And what is the volume? LBH. Cylinder in the same manner, 2 pi RH, 2 pi R in bracket R plus H and pi R square H. Hollow cylinder, that is all in the exercise 9.2 or 9.3, there is one sum in which we will go through this hollow cylinder, right? So 2 pi H in bracket R plus R. This is what the total surface area and this is what the volume. Right, now cone, curved surface area is pi RL, total surface area is pi R in bracket R plus L, and what is the volume? This is the volume, 1/3 pi R square H. Okay, now let's move ahead. Now sphere. In the sphere, the curved surface area and the total surface area remains same, and volume is 4 by 3 pi R cube. Hemisphere, in the hemisphere we need to take care. Why? Because this is the total curved surface area 2 pi R square, but the total surface area is 3 pi R square. What is the volume? So volume is 2 by 3rd pi R cube. Hemispherical cell or hollow sphere, right? So this is the formula for the hollow sphere, curved surface area, total surface area and the volume. Hollow hemispherical cell, right? So you need to go through these formulas and need to learn it. This is our main topic of standard 10. The surface area of combination of solid, right? So here some combinations are given. The combinations are of so many types. Here some combinations are given, and that is cone plus hemisphere, cylinder plus 2 hemispherical end, cylinder with the 2 conical ends, cylinder plus hemisphere, cylinder plus cone, and hemisphere with the cube, right? So these are the 6 basics combinations are given here, right? Let's derive these formulas. Step by step. Some I will do, some you have to do, right? Okay, so now consider the cone plus hemisphere. This is the cone and this is the hemisphere. In this we have to, while find out the surface area, while find out the surface area, we need to take one thing in mind, and that is we need to consider the surfaces which are seen. We need to consider the surfaces which are seen. See here, the curved surface of the cone, curved surface of the cone is seen, and here curved surface of hemisphere, right? Of hemisphere. Now, so what is the answer? We need to simply add the curved surface area of cone. See, surface area is equals to curved surface area of cone plus curved surface area of hemisphere, right? So it's a curved surface area of cone and curved surface area of hemisphere. So what is the curved surface area of cone? That is nothing but the pi r l plus what is the curved surface area of hemisphere, and that is 2 pi r square. Now pi r common, so pi r in bracket, pi r to just take, we'll take pi r common, so what is remain here? L plus here 2 r, right? So this is the surface area. See here, this is the surface area, pi r l plus 2 pi r square, and we'll take out pi r common, so it's a pi r in bracket l plus r. See, whether you take out the common or not, that is totally depends upon you. If you want to take out common, take it out, and if you don't want to, just leave it as it is. But if you take out common, the simplifications will get easier, right? Now let's see the volume. So volume is also same. So volume is what? So that is nothing but the volume of cone plus volume of hemisphere. So now what is the volume of cone? It is 1 upon 3 pi r cube plus what is the volume of hemisphere? That is 2 by 3 pi r cube. So here 1 by 3 pi r 1 by 3, sorry, it's a pi r square h. It's a pi r square h. So 1 upon 3 pi r square common, 1 upon 3 pi r square common, so 1 upon 3, okay, so 1 upon 3 pi r square common. In bracket what is remain? So remaining thing is h plus 2r, right? Okay, so let's see this. See here, right? 1/3 pi r square h, 2/3 pi r cube, and 1/3 pi r square common, so it's nothing but the h plus 2r. And now let's move ahead with the cylinder air, two hemispherical end. In this also, so what is the area of curved surface area of hemisphere? Already seen that, 2 pi r square, right? What about the cylinder? 2 pi r h, 2 pi r square. We simply need to add all this. So 2 plus 2, 4 pi r square, right? So it's a 4 pi r square plus 4 pi r square plus what is the curved surface area of cylinder, and that is 2 pi r h. You can also get 4 pi r square by half hemisphere. Means hemisphere plus hemisphere, it's a sphere. So 4 pi r square plus 2 pi r h. So 2 pi r common, so 2 pi r common. So what is remain? So here remaining is h, sorry, r, and here what? H, right? So 2 pi r in bracket r plus h is the answer. Okay, let's check that answer. right? See here, 2 pi r in bracket r plus h, 2 pi r in bracket r plus h, right? Okay, now see this. Now we need to consider the volume. Okay, so what is the volume? So volume is 2 by 3 pi r cube plus what is the volume of cylinder, and that is pi r square h. What about this? That is nothing but the 2 by 3 pi r cube, right? Now add this and we'll take out the common. Okay, see here, 2 by 3 pi r cube, 2 by 3 pi r cube plus pi r square h plus pi r square h, and 2 by 3 pi r cube, 2 by 3 pi r cube, right? So here see, 2 by 3 plus 2 by 3, it's a 4 by 3 pi r cube. Now take out pi r square common and you will get this answer. Once again, whether you want to take it out common or not, that is totally depends upon you, right? Now this, simply now I'll just write down. No need to explain. Why? Because the things are already explained. Now what is the curved surface area of pi cylinder or a cone, and that is pi r l. This is what pi r l. What about cylinder, and that is 2 pi r h. Now we simply have to add this 3, right? See here, pi r l1 plus pi r l2. Why l1 and l2? Because if the length or a slant height is different, then we have to consider the different notation, right? And here the 2 pi r h, 2 pi r h, right? Okay, now see the volume. So volume is 1/3 pi r square h, 1/3 pi r square h, and 1/3 2 pi r square h. So this is written over here, right? See here, h1 and h2 are taken different. Here this might be, and this may not be a same height, so you can take another different notation, h1 and h2. That is common sense, right? Now this you have to do it yourself, right? And check whether you can get the concept or not. Here in this also we need to see the, it's a pi r l, this is the 2 pi r h as far as area is considered, and if it is volume, it's nothing but the 1/3 pi r square h. And what about this? It is nothing but the pi r square h. So what is the total? So it's a 1/3 plus full, so it's a 3 plus 1, 4 by 3 pi r square h, right? Now this is something important. Now here we have to consider the area of cube. So what is the area of cube? That is 6a square. See, once again I repeat here, the number of surfaces are seen that we have to consider, right? So here first of all take the 6a square. Now see, this surface is covered by the hemisphere, so that is not seen, right? That cover is not seen, but this surface is, this 4 corners are seen, so that we need to consider. So if we'll take the top view, so what is the top view looks like? It looks like the square circumscribing a circle. So what we have to do here, it is simple. See, a square is, this a square is already considered, so simply a square minus this pi r square. Pi r square. Why pi r square? Because area of circle is pi r square. So now 6a square minus pi r square. Now, but this hemisphere is seen. So what about this hemisphere? So that we need to add, and that is pi r square. How many pi r square? 2 pi r square. Now 2 pi r square minus pi r square is equals to pi r square. So 6a square plus pi r square, right? Okay, now let's move ahead. We will see the formula. Now let's solve the exercise 13.1. Two cubes each of volume 64 centimeter cubes are joined end to end. Find out the surface area of the resulting cuboid. Here it is given, it becomes a cuboid. How it is become cuboid? See here in this figure. See 4 4 4, but if we join this 4 plus 4 becomes 8, right? So now this is the cuboid by 4. It's a 4 by 4 by 8 cuboid, right? Now what we have to find? We have to find out the surface area. Now what is the surface area? It's nothing but the 2lb plus bh plus lh, right? So that formula is written here. Simply put the values and you will get the answer 160 centimeter square, right? So this kind of easy sums are there, right? So that's it for today. We'll meet in the next lecture. Till then, solve the worksheet and remember the formula or memorize the formula or whatever you thought. Just go through the formulas. The formulas are the very important part. So just learn the formula. If it is difficult for you or if it is challenging for you, just write down the formulas 2 3 5 times. You'll get remember it, right? So bye bye. Stay home, stay safe.